Good morning. This is Ms. Billerbeck, and we're going to talk about 7.5 factoring ax squared plus bx plus c when a equals 1. So you might see it as x squared plus bx plus c because 1 times x squared is just x squared. So we're going to learn how to use the diamond box. So the diamond box, when we use this, we multiply a times c here, and then we just drop the b down here. So we look for some sort of common, the common factors of the product of a times c. So the factors have to be able to be added. The sum will equal b, but the product will equal the same as a times c. So if we use the letters m and n, that would go right here. So these letters will then be the areas of this box. So mx times nx, and then the first term, ax squared, goes here, and the last term goes here. So then we look for a greatest common factor for this column, a greatest common factor for this column, a greatest common factor for this row, and a greatest common factor for this row. And then when we want to factor ax squared plus bx plus c, we can do so by saying that that's equal to the sum of these greatest common factors times the sum of these greatest common factors. So let's try this out. So if we see we have 1 here, so there's an a equals 1, b equals 13, and c equals 36. So we're going to make a diamond. We're going to do 1 times 36, which is just 36, and b is 13. So then we look at things that are factors of 36. Move this a little bit. And then the sum of factors goes here. All right, so the factors of 36, we have 1 and 36, and its sum is 37. So that's definitely not 13. Then we have 2 times 18, and its sum is 20. 3 times 12, and its sum's 15. And then we have 4 times 9, and its sum is 13. And that's it. So now we found it. Okay, so this will be 4, and this will be 9. So 4 times 9 equals 36. 4 plus 9 equals 13. So now we can go to the box. And we're going to put our first term in here, which is x squared. The last term goes here, 36. Then we found that this is 4x here, and this one is 9x here. So our greatest common factor between x squared and 4x is x. Our greatest common factor between 9x and 36 is 9, and it's a positive 9. Our greatest common factor here is x, and our greatest common factor here between 4x and 36 is 4. So then we found that this factors us x plus 4 times x plus 9. So let's try this one. I'm going to do a diamond here. So we have 1. So a equals 1, b equals 11, and c equals 28. So we have 1 times 28, which is 28. B is 11. So we look at the factors and then the sum. So our factors of 28 are 1 and 28, which is 29, 2 and 14, which is 16. We're getting closer. 4 and 7, and there we have it. It's 11. Okay, so we have 4 and 7 right here. So now we can do the box. So our first term goes here, x squared. Our last term goes here, 28. We have 4 here, so 4x, 7x here. Our greatest common factor between x squared and 4x is x. Greatest common factor between 7x and 28 is 7. Greatest common factor between x squared and 7x is x. And our greatest common factor between 4x and 28 is 4. So we can write this out that this is x plus 4 times x plus 7. Now let's write the factored form of the trinomials of each. So if we do a quick diamond here, so we have a equals 1 times 15, and we have a negative 8 here. And we ask ourselves, what would make a negative 8 when it's added together and a positive 15? Well, that's going to be negative 3 times negative 5. So when you add that together, you get negative 8. But when you multiply negative 3 times negative 15, you get positive 15. So we're going to do a box now. In this box, we're going to do something a little strange, but it's going to make sense. So we're going to put x squared here and 15 here, but we're going to put a minus right there to remember that it took 2 negatives to make that a positive 15, because we need to share the negative with that column and share that negative with that row. So now we're going to put negative 3x here and negative 5x here. So now when we look at the greatest common factor, we have x here for the column. This we have negative 5x and a negative 15. So that means it's negative 5. This one, we have x squared minus 5x, which would be a common factor of x, and negative 3x and negative 15, which is negative 3. So this would factor as x minus 3 times x minus 5. You might be noticing as we do all these factorings with a equals 1 that these diagonal are these here on the diagonals are exactly what you see here. So when a is 1, you don't necessarily need the box, but I want you to have the practice using the box. So many cases, a is not 1, so you will be prepared. So now let's take a look at this. X squared minus 13x plus 42. So we do a quick diamond. We have a is 1 times 42, so we have 42 and a negative 13. So we ask what two things multiply to be a positive 42 and add to be negative 13, and that's negative 6 and negative 7. So then we put this in the box. And we put the first term here, x squared, and 42 here. This is going to be, and we put a negative to remember that that was 2 negatives made that positive. So negative 6x and negative 7x. So now we have a greatest common factor here of x, a greatest common factor between negative 7x and negative 42 would be negative 7. And the greatest common factor for this row is x, and the greatest common factor between negative 6 and negative 42 is negative 6. So this is just going to equal x minus 6 times x minus 7. All right, so you may be catching on now. So let's go a little faster. So we have 1 times negative 14 is negative 14, and this is negative 5. Okay, this one might be a little rough. So let's do a factor sum. Okay, so we know that when we're doing the factors, that the largest of the factors that have a product of negative 14 is negative because our sum is negative. So if we have 14, we'd have a negative 14 times 1 would be negative 13 for the sum. Then we have negative 7 times positive 2 gives us negative 5. Well, that's it. Okay, so now we can do the box. Let me make the box a little nicer there. So this one, we don't have to worry about negative is making it a positive because that's just going to be a negative 14 down here. So we are only going to share that negative with one row or column. So this, we had a negative 7 and a 2 right here. So we're going to put a negative 7x and a 2x. So our greatest common factor here will be x. We have a greatest common factor of 2x, and negative 14 will be a positive 2. Greatest common factor between x squared and 2x is x, and greatest common factor between negative 7x and negative 14 is negative 7. So this will factor as x plus 2 times the quantity x minus 7. All right, so let's take a look at this diamond box. So we have 1 times negative 16 is negative 16 and 6. So now we know we have 1 negative and 1 positive, but the positive factor is the greatest factor of the factors is positive. So if we look at that, factor sum. So we want negative 16. So we have 16 times negative 1 would give us 15. Then we have 8 times negative 2, and that gives us 6. So there it is. So we put 8 and negative 2, which make negative 16. The product is negative 16, and the sum is positive 6. So now we do a quick box. And we put the first term here, x squared, last term here, negative 16, 8x here, and negative 2x here. So our greatest common factor here is x. Greatest common factor between negative 2x and negative 16 is negative 2. And greatest common factor for this row is x. And greatest common factor for this row, 8x and negative 16, is positive 8. So then we find that this factors as x minus 2 times x plus 8. All right, here we go. Let's make this a tad more complicated now. We're going to put in a couple more variables. Right, so we do a diamond and we have 1 times, and we have 32y squared. And then this one is, the middle term is 12y. So we have 32y squared right here. Okay, so we look at, well, what multiplies to be 32 and adds to be 12? So let's go ahead and do a factor sum. Okay, we know we're dealing with only positives. So the factors of 32 are 32, 1, so that's 33. Then we have 16 times 2 gives us 18. And we also have 8 times 4, which gives us 12. So that's what we're looking for. And one of these has a y. So we have 8 and 4, and one of them has a y. We do not know which one yet. Okay, so let's put it with the 8 just to see. Okay, we'll check it and then we'll see if it works. Oh, you know what? They both have a y. Huh, there we go. Because you have to, if you're going to add them, they have to be like terms. So if we add 8y plus 4y, that equals 12y. If we multiply 8y times 4y, that equals 32y squared. So they both have a y. Okay, so then the first term here is x squared. The last term is 32y squared. Then we have 8, and remember x is involved with this, so it's 8xy, because we usually go in alphabetical order of the variables. And then 4xy here. All right, so we look for our common factor here is x. Our common factor here is 4y. The common factor here is x, and the common factor here is 8y. Again, we can see what those two will be from these parts of the diagonals. So then this is going to factor as x plus 4y times x plus 8y. So there you go. So 4xy plus 8xy would be 12y, and 4y times 8y is 32y squared. So we've got it. Okay, let's try that again. All right, so our first term is 1. For a is 1, then we have 21y squared. So here we have 21y squared. Then we have negative 10y. So we're looking for two negatives that make a positive and they multiply to be 21. So that would be negative 3y and negative 7y. Negative 3 times negative 7 is positive 21, and negative 3y times negative 7y is positive 21y squared. Negative 3y plus negative 7y is negative 10y. So now let's do the box. So here we go. We put the first term here, last term here, side term here, and we put an x with it. Another side term here, and we put an x with it. So now we look for common factors. X is here. We have a negative. Oh, remember this is a negative negative. So we've got to share the negative with this column and this row. So it took two negatives to make that a positive. So this gives me a negative 7y and I have a greatest common factor here of x, and the greatest common factor here is negative 3y. So this one will be x minus 3y times x minus 7y. All right, let's look at a real life problem. So what's the largest possible closet organization for an organizer with one square with the sides of x length? So that'd be x times x, is we have one organizer that's x times x. And then we're going to put together with that 12 organizers with a 1 foot side by x side. So 1 times x, and there's going to be 12 of those. And then we have 11 1 foot squares. So we have 11 times the 1 times 1 squares. All right, so let's take a look at what that might be. So we have x squared plus, and this is just 12x plus 11. So we can do a diamond box. We put 1 times, there's a 1 right here, 11. So 11 here. So 12 is here. So 11 is prime. So we know that this has to be 1 and 11. So when we do the box and find the area of the box, the first term goes here, x squared. The last term goes here, 11, and we have 1x and 11x. So our greatest common factor here is x, greatest common factor here is plus 11, greatest common factor here is x, and greatest common factor here is plus 1. So we want the largest possible closet organization system. So the largest width and height for the wall. So we have x plus 1 and x plus 11. So we have the width will be x plus 11 feet for the width, because we want a longer width. And then the height will be an x plus 1 feet height. So now we can just vary our proportions of what x is going to be, and then we can fit the biggest wall organization system, closet organization system that we can in our closet. All right, so that's how you might use this in real life. All right, have a wonderful day. Bye-bye.